Hi, in this video I'm going to discuss compound mixtures involving up to 3 mixtures. This is a sequel to my prior video, so if you have not watched my prior video on mixtures and alligation, I would request you to please have a look at that because this video will have elements which will be of a higher level than what was discussed in the previous video. In the previous video, we had looked at mixtures involving two substances or two mixtures. But in this video, I'm going to discuss with you compound mixtures involving three substances or three mixtures. Alright, let's take up compound mixtures involving three mixtures. So what happens when three solutions are mixed? Let's take one question to elucidate this point. Given three sugar solutions of 50%, 20% and 5% strength, how should the three solutions be mixed to get a 600 milliliter solution of 10% strength? So this is a different kind of problem. Here it involves three mixtures, right? To get a compound mixture of a particular strength and the volume is also given, right? So if you want, you can try this. Otherwise, look at the solution, then maybe you can try the next one for practice. Okay, let's look at the solution. So the smart way is that you take the mean strength given as 10%, make two groups, one above the mean and the other below the mean, that is the desired value. So you make this matrix. You put the mean strength as 10%, that is what is given. This is given as 10%. These are the individual values and this is the volume of the final solution of that mean strength 10%. So put that 10% in the center, make two rows above the 10 and two rows below. Why two rows below? Because even though we have three quantities, why do we need the fourth one? This is, we duplicate the last row or the last unit over here because we want to balance what is above the mean, the values above the mean and the values which are below the mean. So there are two values above the mean, so we have to have two values below the mean or the desired value. This is the process. As we move forward, I'll tell you the logic as well. Please follow the method here. What we do, we put 10 in between and we see the differences. So top left hand side is 50, 50 minus 10 is 40, so 40 comes at the bottom right. Topmost 50, bottommost 40. That is how it is. 20, this corroborates with this 10, so 20 minus 10 is this 10. So last but one from the bottom. Here 10 minus 5 is 5 and then 10 minus 5 is 5, same method. So what we get is 5, 5, 10 and 40. You divide it by 5, all the values can be divided by 5. What you get is 1, 1, 2 and 8. Now combine this 2 and 8 to get 10. Why? Because one part is this 50% solution, the other part is this 20% solution, that is also one part. But 5% solution, how many parts are there? 2 and 8. So add them to get 10. So there are 10 parts. So the ratio of 50% is to 20% is to 5% solution. In order to get a 10% solution would be 1 is to 1 is to 10. That is the answer. But what was asked? How should the three solutions be mixed to get a 600 ml solution of 10% strength? So only the ratio is not sufficient. What we need to do is, how do we need to mix these particular solutions having strength of 50%, 20% and 5% to get 600 ml solution. So we need to prepare that 600 ml solution. So now we are in the realm of ratios. We got the ratios 1 to 1 to 10 and we need to distribute 600 ml in that ratio. 1 plus 1 plus 10, that is 12 parts. Let's say 12x. 12x equals to 600. So one part is 600 by 12, that is 50. That becomes a one part. So the 50% solution, the ratio is one part. It is one part. So you get 50 ml, 20% solution is again one part, so you get 50 ml, and 5% solution, there are 10 parts of it, so you get 10 into 50, that is 500 ml. So that's your final answer. 50 ml, 50 ml and 500 ml. 50% is to 20% is to 5. That's your answer. I hope this is clear. Now let us understand the logic behind that method. See, there were three solutions, 50% strength, 20% strength and 5% strength. They were mixed to get a solution with mean concentration of 10%. So 10%, look at the values. 50 and 20 are above 10, 5 is below 10. So these are the two different groups that are working together to give you 10. But can you take 50 and 20 to get 10%? No. You will never be able to get a 10% solution if you take 50% strength and 20% solution, because there the average will always remain between 20 and 50. So what you need to do in order to get 10% solution, either you can take 50 and 5, or you can take 20 and 5. 10 will remain in between these two values, 5 and 20. 10 will remain in between 5 and 50. So using the method of alligation that we learned in the prior video on the topic, you know that the difference is 10 minus 5 is 5, 50 minus 10 is 40. Here the difference is 10 minus 5 is 5 and 20 minus 10 is 10. This is how you get 10. This 50 is the first solution that which has a 50% strength, so I will call Q50. That means I'm talking about the quantity of the solution that has a 50% concentration. So Q50 over Q5 will be the same in that same sequence, 5 upon 40. You can convert it to 1 upon 8, and here Q20 over Q5 will be equal to 5 upon 10 for the same reasons, and you can convert it to 1 over 2. So essentially what you get is Q50 is to Q20, that is quantity of 50% solution is to quantity of 20% solution is to quantity of 5% strength solution would be how much? Either you can take the straight away values, you can take the original values, that is 5 is to 5, and then Q5 is 40 plus 10, that is 50 parts, right? So either you can take this or you can take the converted values. Both will give you the same answer, 1 is to 1 is to 10. Because you divide this by 5, so you will get 1 is to 1 is to 50 divided by 5 will be 10. Or you take this 1 and then 1, so you get 1, 1. Q50 is to Q20 and Q5 is 8 plus 2, that is 10. Either which way you get the same answer. Alright, so let's now do one final practice problem question on this particular topic, that is mixing 3 substances or 3 mixtures to get a compound mixture. I request you to please pause this video, try this out, and then come back for the final answer. Alright, now let's read the question. In what ratio should you mix 3 types of sugars, sugar 1, sugar 2 and sugar 3, costing rupees 80 per kg, rupees 70 per kg and rupees 50 per kg respectively, to get the average or mean cost of the mixture as rupees 60 per kg? Let's look at the solution. So sugar 1 is rupees 80 per kg, sugar 2 is rupees 70 per kg, sugar 3 is rupees 50 per kg. The average cost that we need out of mixing all the 3 different types of sugar is rupees 60 per kg. So we know that 80 and 70 will be above the mean. So make one group 80 and 70 and the other group is 50, which is below the mean, right? We already know from the prior example that we can use this method. We will just put 60 in between, make 2 rows above, 2 rows below, and then total, and 1 column on the left of 60 and 1 column on the right of 60. We put the values in sequence, starting with the highest one, 80 followed by 70, and then 60 is the average. What is below the mean is, 60 is the desired value or the average of the mean value or the mean concentration. What is below 60 is 50, and we need to duplicate this 50 in the last row. Why? Because we want to balance the number of quantities above the mean and the number of quantities below the mean. So we know the process. Now just take the differences. 80 minus 60 is 20, 70 minus 60 is 10, 60 minus 50 is 10, 60 minus 50 is 10. That's how you go. So here we see 10, 10, 10 and 20. So clearly either you can take the straight values. So S1 is to S2 is to S3 will be 10 is to 10 is to 30. Or you divide everything by 10. So you get the simple ratio 1 is to 1 is to 3. That becomes your final answer. Before we end this video, let us check our answer. Let us see whether 1 is to 1 is to 3 is the correct answer. How do we check? So the prices are 80 rupees per kg, 70 and 50 rupees per kg for the different kinds of sugar. Let us mix the sugar of each type in the ratio 1 is to 1 is to 3. In this problem, what we are going to do is, we are going to take this ratio and we are going to see whether after mixing the 3 different types of sugar in the stated ratio, whether we get the average price of the mixture as rupees 60 per kg. If yes, then the ratio will stand verified. That is, our answer will stand verified. We mix each type, but in that ratio, same ratio. So we will, first sugar type will cost us 80 rupees, second type of sugar will cost us 70 rupees, and the third type, that is C3, will cost is how much? There are 3 parts, so it will 50 rupees per kg. So you'll have to take 3 kgs of that. So that will be 50 into 3, that is 150 rupees. So what will be the mixture cost? Mixture cost will be 80 plus 70 plus 150, that is 300 rupees. Whereas the mixture quantity is 1 plus 1 plus 3, that is 5 kg. So what is the average mixture cost? 300 divided by 5, that is rupees 60 per kg. That's our answer. So that means our answer 1:1:3 that we found in the previous question, that stands verified. So that brings us to the end of this video. I hope you liked the content. If yes, please do like, subscribe and share. Your support means a lot to us. If you want me to take up any other topic, please mention it in the comment section. If you need any further assistance, you may visit my website succeedeazy.com to book a session with me. I hope to see you in my next video very soon. Thank you so much. Happy learning. Till then.